hi class. Um, we're going to do a problem involving some colored marbles. Let's switch that down so you can actually see it. We're going to have 4 marbles, and this problem is going to involve not necessarily equal chances of getting the same outcome. So far we've been doing, you have one of each color, and you have a completely random and equal chance and equal probability of choosing any of these. But what happens when we change it up a little bit? What if I have 30 red marbles and 1 blue marble? Of course, the 30 red, the chance that you choose a red one is much, much higher than that 1 blue. Okay, so we're going to have red, red, and we're going to have blue and green. We're going to start small with just 4. Okay, all right. So this problem is going to involve us drawing. So we have a bag. You put a red, a blue, and a green marble inside of that bag, and you draw without looking, and you should have equal chance of getting all 4 of those marbles. But it starts to get a little icky if I have 15 red marbles, a blue, and a green. That's a lot of branches to do on my tree. It's a lot. So is there a way I can combine all the reds into one fraction, so I only have to do 1 branch? Oh yes, oh yes, oh yes. And that's what I'm going to be showing you. So we need to first look at, hey, if I have a 1/4 chance, a 1/4 chance, a 1/4 chance of just one time reaching in and grabbing it, we're going to do it 2 times. So you're going to draw the marble in your brain. You're going to draw it out of a bag, take a look at it, and then put it back into the bag and draw a second marble randomly, hopefully. And we're going to mark those probabilities. Okay, so we already know we've got 1 in 4 chance of getting green, 1 in 4 chance of getting blue, but we have 2 1/4 chances, and we're going to start off by combining them. Okay, therefore we're going to combine you 2 together, and then you're going to be separate and you're going to be separate. So instead of having our normal 4 branches, we are going to have 3 branches, and this is where, since we have 3 options, this is where marking on every single one of those branches the correct probability fraction is so very important. So the chances of getting red, blue, or green are no longer precisely exactly the same probability. Okay, we're going to combine a 1/4 and a 1/4. So getting red, that could be either red marble. There's 2 marbles in this, but we're going to have the probability. We're going to have it be 2/4. Okay, or you could change it to be 1/2. I like to keep it as 4ths. I like the denominator to stay the same. We can do it either way. It is up to you. And this is going to stay 1/4, and this is still going to stay 1/4. Okay. Yeah, let's do it that way. Good. Now, that looks pretty good. From here, it's a lot less messy. I didn't have to draw how many different lines I needed to draw, so that's a really big positive. So this represented the very first draw, like reaching in, grabbing out some marbles. Now, we need to do the second draw. You put the marble back inside of the bag, and you draw a second time. Okay, and remember, even though there's only 3 lines, this actually represents 2 marbles. Okay, so now second draw, second event, and we're going to draw the same 3 options out of all of the ends of these branches. Okay, and we're going to have again red and blue and green, but this saves us a little bit of time. Red, blue, and green. Okay. Which is excellent. And I purposely chose red, blue, green, and not blue, black, brown, because I like colors with different starting letters so that you can abbreviate them once we get really crazy into lots of different options and lots of different choices. So it makes it a little bit easier on you guys. So now on each of these branches, so ignore that first one, but hey, once again, this red is representing 2 of our marbles. But we just want to know, did the color happen? Did you choose red? Yeah, you have a 2 out of 4 chance of getting red. That's our option That's our outcome. We want to know what actually could we get, okay? And that's the color, not necessarily which marble, okay? And the same stays the same for blue. Sorry, the probability stays the same for blue. Here, get 2/4 because it's red. 1/4, 1/4. Here again, 2/4, 1/4, and 1/4. So from here, it looks pretty fantastic. It's a little light, but it works. 1/4, 1/4, 2/4, 2/4. Everyone's labeled along all the branches. If that's true, then now we can get to our outcomes. And our outcomes might look a little bit different this time around. Okay? So we're going to start by listing out all the color combinations. Okay? So we're going to start at our start. We're going to follow this branch, and we're going to write red, red. Red and blue. So this time I'm saving some time in that I don't have to write out each individual red marble, and I like saving time. Yet I'm still going to get the correct answer, and I'm still going to be showing my work adequately. Okay. And there you go. Now, we've listed out all the possible color combinations. Now we're going to have to go back and be very cautious and very careful because this is a little bit different. We're going to fill out from the start what are going to be the fraction probabilities. What are the fractions of this probability of getting red? Well, in this case, since there's two reds, it's going to be 2/4. Okay, and we're going to multiply that. Red and red again is 2/4. Okay, and then we're going to keep following along. So we've got red and blue, and that's going to be 2/4 and 1/4. Notice these guys are a little bit different. 2/4 times 1/4. Okay, so these are going to be different ending probabilities, and we just have to be really, really cautious that we're multiplying correctly. As a reminder, when we're multiplying, okay, we've got like denominators, pretty easy. Like, they're so strangely like numerators on this one. We multiply straight across. That's how we multiply, okay? So 2 times 2, of course, is 4, and 4 times 4 is 16. I like to put things in those terms, but you don't have to, okay? At least for me. In this case, we're going to multiply across for red, blue, and it's 2 times 1 is 2, and that would be 16ths, and that's the same as 1/8. I'm keeping track of this column right here just for fun. And then the same thing, 2 times 1 is 2, and 4 times 4 is 16, which is also 1/8. Okay, 1/8. Now, what I'm paying attention to right here is because if I do this right, which I will, when I add up all of this column, it will hopefully equal 16. Okay, so let's fill it on out. So here they're all filled out, and what I'm looking for is that this, whoops, this column right here, if I add up the 4 and the 2 and the 2 and the 2, that's at 10, 11, 12, 13, 14, 15, 16. If I add them up all correctly, which I should be left with 16 over 16, which is good, which is equal to 1, which is equal to 100%, which means I'm amazing, okay? That's a lot faster and a lot easier and a lot smaller. I'm going to flip and show you another one that I did a little bit earlier, and I spread it out a little bit differently, okay? So in this case, I kept the marbles separate, okay? And instead of combining the two reds into one probability, I kept them as 1/4, 1/4, 1/4, because a lot of us are really, really used to, and we find it easier when all the probabilities are exactly precisely the same. Then there's, no thinking, no converting of fractions. It's easier on our brains. It's fine. And generally you can do that. You cannot always do that, okay? So don't get too used to it. But in this case, we kept the 1/4, 1/4, but we had to do a lot more writing. It's a lot more. Oh my gosh, like look at that. I had to do so much more, and it took a lot longer. It really, really did. In my opinion, put them like side by side just to kind of show you, right? Which one is a little bit easier? Well, this one's smaller, and I don't think it's too hard working with 2/4 versus with 1/4. And then taking a look at the outcomes too. This one just like kept going. It's a very, very long process. So personally, I prefer this way, but if this is easier for you and your brain, then more power to you. You do what makes sense to you. But I just wanted to give you two different options so that you can choose the one that is best for you. You will obviously get the exact same answer. You will obviously still have the words of combinations. All of them were available and spelled out. We didn't lose any when we combined them. And so it's no big deal which one you choose. Just you have to kind of choose one and go with it.